All right. We're getting things kicked off here. Made some changes, hopefully for the better. Hoping the streaming quality is going to be good. I lowered the latency. I'm being a little ambitious doing this. I'm not adding a delay, so I'm hoping that it's not going to be choppy. Do feel free, let me know, post in the thread. I will be monitoring the thread in the study hall channel that I posted in. So post in the thread, let me know if the latency is okay, if the streaming quality is okay, and I'll be able to adjust accordingly. Also, let me know, it seems like my audio might be a little bit quiet. I think I could actually turn this up. I'm actually going to turn this up a little bit. All right, just be forewarned. Test, test, test. Check, check, check. 1, 2, 3. 1, 2, 3. All right, this could go up a little more. Check, check, check. Testing, testing, testing. Check, 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 check. Okay, that looks. Oh, nope, that's peaking. All right, I thought that was a little high. Okay, all right, there. Okay, good. Sorry about that. Still doing kind of final system checks on this. Okay. So, welcome to Study Hall. As usual, this is a place for you all to ask questions, bring your questions, whatever you want to know regarding any Python questions. I'll be happy to take those questions on Study Hall stream. Yeah. Let me just adjust that. All right. Okay, there we go. So yeah, just post any links you have in Learn. Like if you're working on a question in Learn and you want help with it, I'll post a link to it so I'll be able to find it. A lot of times people will just send me code and be like, "What's wrong with this?" And I'm like, "Well, I don't know what it's supposed to do, so I can't tell you what's wrong with it if I don't have a clear idea of what it's supposed to do." And I don't have, I've probably seen all the questions on Learn at this point, but I don't have them necessarily memorized by just the function name. So yeah, if you send in the link, I'll be able to take it quickly, and yeah, we'll go from there. Cool. All right, so I'm not seeing any questions at the moment. So last time we left off on, we hardly, I don't think we went through any material last time, which is kind of good. It's kind of a good sign. But yeah, last time we went through material, we left off on this section of removing dictionary keys and values. And I did the prior two challenges, so I'll do a recap. I think I did a recap. I think I got as far as a recap last time, but I'll do a quick recap here. We have a dictionary. We'll just put some, I'm going to do the car dictionary thing. That's what I always do. Model, or let's do, oops, make. Make is and we'll say model is a Camry, something like that. So if I want to delete elements from a dictionary, I really have two tools, two things I can use. I can use del and I can use pop. So let's just print the dictionary just to prove that we can. I'm printing it twice so we can see a sort of a before and after. So one thing, if I want to delete the whole dictionary, and this doesn't just apply to dictionaries, this applies to literally any variable, any data of any data type. I can just delete the whole variable like this, and we'll actually get a name error. So I scroll up here, notice this first one does print, make and model, but we get a name error, and this is the same error that we would get if this was never even defined. It's a pretty useful thing to be able to do, and you can see in this case we actually get the error on the first one because we don't get that, it doesn't print off, right? So that's one aspect of deleting dictionaries. Usually, and this is more focused on just deleting a certain key value pair. So usually that's what we want to do. We don't want to delete the whole thing. So I can delete the dictionary at a certain, or I can delete a key value pair from the dictionary. And the way I can do that is just d sub key name. So if I do make, you can see this is going to give me this output here. And there we go. So that's our before and after. I'll do another one here. We have another tool, which is pop. So I can say d.pop make, and you can see that this is going to have actually the same result. So we're actually going to get the same result here. If I wanted to capture the make key value pair at make, I can use pop and actually capture it. So let's just call this res equals d.pop make, and we can print res as well, and that'll prove that we can capture that. And you can see this is actually just going to return the value. I said key value pair, but it actually just returns the value. So Toyota, oops, like that. So pop is useful for not only for removing, but removing and capturing the value at that key. Notice past this pop, the key is unrecoverable unless you just know it independently, but you don't get that from Rust like that. Okay, so those are our two things. We can do del and pop to remove. So notice in either case, we have to know the key, and if we know the key, we can remove the value, the key value pair at that key. Somebody will always ask, like, well, what if I know the value and I want to remove the key? Things get a little funky here because of the arbitrary ordering of dictionaries. Since dictionaries don't guarantee an order, that means, how do I put this? You might be able to think through this on your own, right? Like, we can't have duplicate keys. This is one thing, and this is one reason why it makes sense to supply the key that we want to delete, right? Because it's definitive, right? If that key exists in the dictionary, then it only exists once. So we can objectively, definitely remove the key at that location. It occurs to me, what if we ask for a key like horsepower, something that's not in there? So this is going to give us a key error. So with either of these approaches, and we would actually get the same thing if we did delete up here. If we tried to remove a key that's not in the dictionary, either approach that we use, if the key's not in the dictionary, we're going to get a key error. So we would have to, have a protection in either case, something like key to remove equals make, and then if key to remove in d.keys, right? So we'd have to do some sort of protection like this before we would, and then obviously put in key to remove in the place where we'd want to remove it. So it'll be whatever we ask for. So you might have to do a little checking just to make sure you don't get errors. Actually, just comment these out. There we go. But, you know, presuming that the key is in there, there's only one of it, right? We can't have multiples of the same key. So there can be, a dictionary can have keys where 2 or more keys can have exactly the same value. So values may or may not be duplicated. Keys definitely are not duplicated. So with a list, you have the remove method, which, given an element in the list, will remove the first occurrence of that element, right? Since there is a first occurrence, there can be a first occurrence because lists have an order. Dictionaries don't guarantee an order. Their order is arbitrary. And by arbitrary, I was thinking about this today. By arbitrary, I don't mean random. Randomness is different from arbitrariness because something that's random is unpredictable by design, whereas something that's arbitrary is unpredictable. It's unpredictably unpredictable. It's not unpredictable by design. It's unpredictable just kind of by happenstance, right? So it's not designed to come out in a different order every time. It's designed for the order to not matter. So sometimes you will notice that the keys in your dictionary are ordered. Sometimes they'll be sorted even, and sometimes they won't be. And that's up to the Python interpreter to make that decision about how to best optimize storing and handling the elements in whatever order it wants to. So basically you're handing it over to the Python interpreter and saying, like, you know, you figure out what order you want to deal with these things in, and I as the programmer, we as the programmers don't have access to that process. It's sort of a black box. And that's just a limitation of the dictionary type. So since it doesn't have an order, what would it mean to remove a key value pair given the value? You know, that would be a essentially you'd pull out an arbitrary key value pair that has that value. Another way of approaching it is you could remove all of the key value pairs that have that value. Maybe that's what you wanted to do, but that could potentially lead to unforeseen results. At any rate, if you did want that behavior, you could write a function that does that pretty easily. And yeah, it would just be basically a loop, and then, you know, once you find your, you know, 4kv in dict.items, if the value matches the value that you want to remove, then you just do one of these to the key. You do need to iterate through a copy and remove from a different copy, otherwise you'll get an error. So anyways, that's the whole thing. So I know every time I go over this, somebody will always ask me, like, well, how do this is great, these methods are great if I want to remove an element and I know the key, but what if I don't know the key and I know the value? And to be honest, I've never found myself in a situation like that, really, where I needed to do that, other than just for fun writing a function that returns a version of the dictionary with key value pairs removed given a value, you know. So I've done it just to do it, but I've never found myself in a situation where I've needed to do that. Not to say that you won't, but yeah, it's just me. Okay, cool. So let's do this last remove one here. Delete dups. Actually, this is probably such a function. This is probably the function in learn that I've been thinking of that has you do that. So I'll just copy paste this into my environment here. Okay, so write a function called delete dups. Actually, sorry, let me turn off. I turned on my autocompletes for, I was doing C++ earlier today, and I like it for C++, but I do not like it for Python. Let me just turn those off. I should just search for the package really quick. Autocomplete plus. And then that's show. Let me see if I can just do .py. Can I just blacklist Python files? No, I can't. Alas, okay, I'll just turn it off. I'll have to just come back here every time I do C++. For now. I'm sure there's a way to set that up, but okay, sorry about that. Okay. Delete dups. Okay, so write a function called delete duplicates. This function should take in a dictionary as an argument. I'll say some dome, some d, and we'll say some d equals, let's just see what this is going to be. This function should take your dictionary as an argument. The function should go through the values inside the dictionary and remove any key value pairs where that occur more than once inside the dictionary. Okay. So, you know, I think I did do this on stream last time. Whatever. Learn says I didn't do it. I don't know why, so whatever, I'll just do it again. Okay, so let's say okay, function should go through the values inside the dictionary and remove the key value pairs where the value, right? So this is a remove by value, and I'm just going to kind of highlight that like that. There, I'll do this just to make it clear. So key value pairs where the value occurs more than once inside the dictionary. Okay, so we'll just say A, B, C, D, and F, G, E, F, G. Okay, so the value 1, 1, 1, 2, 3, 2, 4. Okay. G, H. We'll add in an H. Okay, so my duplicates. So here's my input dictionary. I'll call this imp_d. And then let's have an exp for expectation. So our expectation is going to be, we want these ones removed. We want to keep in. Oh wait, do I remove all the duplicates? That's the interesting. The function should remove the second occurrence and the third and fourth occurrence if they're available, not the first occurrence. So this is kind of a weird one. It's talking about the dictionary as if it's ordered. This is actually a situation in which we can count on an order. It's going to test it in a way where it can count on an order. So all that stuff I said about being arbitrary, sometimes it goes out the window. So we're going to keep the first element. So we'll keep A, and we'll keep D, but we'll delete F. So 1, 2, 3, 4, 5. Okay, cool. So that's what we're expecting. And let's just do this. Res D equals this, and I'll say exp D equals res D. So this is going to check, does our expectation match our result? And then we'll print the res D like that. Okay, cool. So all that work, and we've just written the test. I encourage you to work similarly. There's a reason I put energy into the tests beforehand. A small problem like this, I don't, like if I'm actually doing something like this, I probably won't make the test. But, if you're just learning, when I'm learning a new language for a problem like this, I definitely would make the tests ahead of time because it saves you a lot of trouble. Okay, there we go. We'll do that. Delete dups. So first thing I think I want to do is we'll say D equals dictionary like this. And there's a few ways we could do this. For K, V, and imp D. I guess we could just say if V not in D dot values, D sub K equals V. Yeah. And then return D. So, yeah, I definitely remember as I'm doing this, as I'm writing this, I'm like, oh yeah, I apologize, because I definitely did this last study hall. I totally did this question last study hall. I don't know why it said I didn't. Maybe I need to like refresh the page or something. I don't know. Anyways, yeah, I think this will work. We'll see. Oh, we got a problem here. Value errors, not enough value. Oh, right. I forgot to do dot items. Totally just forgot it. Okay. So true, that means our test is passing and we got the correct dictionary as a result. Okay, good. So I remember doing this because I was just going to say I'm showing a solution here that doesn't involve a remove approach. I find this kind of solution easier, right? It's usually, if you can get away with it, and every now and again you can't get away with it, but usually when you're looking at a problem and you have this conception of like, oh, I'm gonna take this thing and shrink its size down, usually you can get away with reframing your approach to, I'm just gonna start with something empty and build it up from scratch. It's usually easier to manage something that you're starting with and building onto, rather than something that you're starting with and taking away from. So I guess what I'm saying is like so-called, let's say additive approaches tend to be easier than subtractive approaches. So in this case, this is additive because we start with an empty dictionary and then we add in key value pairs as necessary. Even though this is in the remove section, so obviously it's asking us to like start with a full dictionary and then remove the elements. So we can do that too, but we'll just kind of A/B this, and you'll see why I prefer this. It almost always makes for just simpler, easier to deal with, easier to read, easier to write, easier to handle code. So, and often it's just more efficient too. It's often more performant, less error prone. So yeah, lots of benefits. And it's not to say that like subtractive solutions should always be avoided. I think there's a good time kind of shy away from, well, no, I don't. There are some things that I say should always be avoided. Okay, anyways. Sometimes subtractive solutions are fine. Sometimes they are more optimal. Sometimes they're perfectly safe. Sometimes they're not quite as safe, but they're still worth it because they're so much more optimal. But yeah, that's a whole other kind of can of worms. But yeah, let's just look at a subtractive solution for this. So first of all, I need to, when you're doing a subtractive solution, you have to be careful. Actually, let's look at this. Gosh, I remember doing all of this last study hall, but whatever. I think this is a kind of a good function to go over a second time, because there's kind of a lot of good principles that we can explore in here, right? So one, right now, we can kind of explore mutability, right? So if I'll just clean slate here. Okay, so we'll just start from scratch. So if I say I'm going to take a subtractive solution, we'll say 4k v in imp d dot items. And I'll say if v, how do I want to do this? I think we'll need to create a scene list. Yep. Scene list equals this. We'll say if v in scene list, I think it's actually if v not in scene list, then we will. Oh no! Okay, so sorry. If it's in scene list, flip-flopping. Okay, I'm going with not. Okay, if it's not in scene list, all right, sorry about the flip-flopping there. If v not in scene list, we'll scene list dot append. V else v, we'll say v is in scene list. This means we've seen that value before. So if we've seen it before and it's coming up again, we want to delete it from the dictionary. So we'll say, well, let's do del, and I could do del or pop here. It doesn't matter. Del imp d sub. Okay. There we go. Okay, so I wanted to show this solution so we'd get this error. I kind of embarrassed myself on this error last time because I tried to reproduce it to kind of talk about it more, and I wasn't able to reproduce it with a list. But we will. I know for sure we'll get this error for dictionaries. So this is a runtime error. And it says dictionary changed size during iteration. And this is a special error because if you look at this, we're iterating through the same object that we're actually mutating. And last time, if you recall, I was really confused because I tried to do the same thing with a list, and it actually let me do it. It actually let me iterate through a list and remove from that list at the same time, and it led to really unpredictable results. And that's what errors are. That's why they exist, is to like help you avoid weird, unpredictable results. So fortunately, we do get an error when we're trying to do this with a dictionary. So in order to avoid this, we want to iterate through a different object than we're removing from. So I can chain these methods together. I can say input dictionary dot copy, which is going to give me a different object with the same values. It's a different dictionary with exactly the same state, but it's just a duplicate object, right? So then I can do dot items, and then this should work. So this will work, but we have a pretty terrible side effect, and some of you may have seen this. You may know where I'm going with this. So, okay, let's come back down here. So here's my input dictionary. It's some dictionary from somewhere out in userland, out in the world, and it's my program's data or whatever it is, and I pass it into the function, and what do you think happens to it? So you can probably deduce what's happening to it based on how I'm talking about it. Let's just make this clear. Ah, I knew that was too many. Okay. So let's do this twice. Let's do this before we call the function, and then after we call the function. So here's the original. Notice it's got all its stuff in it. And then here's the result, and here's the after. So before it has all the stuff in it, and after it has the stuff removed. So if it's not clear, this is a pattern that should always be avoided whenever possible. I think you could make an argument that sometimes there are cases when maybe you kind of have to do this. Other languages kind of make this kind of thing sort of is mandatory, but in Python, it's something that I've always been able to avoid. And specifically, what is to be avoided here is you want to always avoid writing a function that mutates its inputs, right? So this function, as written, takes in the input dictionary and alters the object that was passed to it. It alters the input dictionary here, right? So a way we could get around this actually is, rather than doing the copy here, we could iterate through the input dictionary and then do something like d equals imp d dot copy, like that. And then we'll remove from d and return d. And now if I do this, we still have a subtractive accumulator, or decrementation pattern instead of accumulation, if you want to call it that. We still have a subtractive solution. If you're really committed to a subtractive solution, we still have a subtractive solution, and we're not mutating our inputs. So for a subtractive solution, this is a good one. Now let's take an opportunity here to kind of look at these solutions side by side, and we'll look at the solution. I think the suggested solution is, yeah, it's essentially exactly what I have here. The things are named differently in a little bit of a different order, but it's exactly the same. Or I mean, it's logically the same, you know. So Okay, so I find this first function to just be like, personally, and this is because I've written and looks like this, I find this first function to be just trivially easy to deal with. I look at it and just the shape of it, empty dictionary, for KV and items, if some condition, uh, accumulate, right? Like I know what this is doing in an abstract before I even, like, I could unfocus my eyes and not even see any of the characters, and I know what this is doing because I see this obvious accumulator, I see this obvious loop, obvious change to the accumulator, return the accumulator, right? This is such a vanilla standard solution, and when I say vanilla, I mean that to be a good thing. It's just easy code that it's easy to produce, it's easy to read, it's easy to write. This solution, it's not terribly complicated, but it has a bit more going on. And if we actually look at this, it's not even more efficient in this case, right? In either case, actually this one is going to be slightly more memory efficient because we start with an empty dictionary and we only grow it to the point that it needs to be grown to. So we do have some information duplication here, but it's kept to a minimum. This, we set aside enough space in our memory to hold an entire copy of the dictionary and then pare it down, right? And that extra space that gets abandoned, or that gets deallocated in memory, doesn't necessarily get recovered by the rest of the program instantly or efficiently or at all. Potentially, right? So that potentially, that's just ends up being, if we start with a dictionary this size and we remove a whole bunch of elements from it and we get to a dictionary that's this size in the end, that leftover memory where we took that information from might just linger in the program's memory for a while. And if it looks like we've got some streaming issues here, let me see. Okay. Let me know if the stream is doing all right on your end. Cool. I might have to put that latency back in. Okay. Apologies if there's like a lot of extra buffering or whatnot. Coming and going. Okay. Alas. May have to restart the stream. Whew. Okay. Let me actually do that. Okay. I'm going to just restart stream really quick. Sorry about this. And yeah, I'll just repost the link.